Hello everyone, this is Shemonto and we are going to demonstrate our CSE461 final project where we are given a task of making a maze solver robot where our team consisting of 4 members alongside me, every 3 other member alongside me have constructed a maze solver robot where me, myself and Mehdi Hassan has worked with the circuit and the hardware part. Shoaib Ahmed Dipu has worked with the coding part, and Naeem, our other group member, he has worked with the MIT app Inventor. Though we have collaborated throughout the project, but for the discussion purpose, for the convenience of the discussion, we are going to describe it in 3 different sectors. So first, if we start with the circuit, we are seeing here that we have connected the positive and negative end of the LiPo with the positive 12 volt and the ground of the motor driver respectively, as we want to mention it explicitly that we are using a lipo rechargeable lipo battery here. Then what we did is we have connected the nano pin port to the motor driver 5 volt pin, and the upper pin to the enable pin, and the nano ground to the motor driver ground. Then we have connected the motor driver ports IN1 and LN1 and IN2 to Nano 9 and 10, and IN3 and IN4 to Nano 11 and 12 number pin respectively. And we have also connected the enable A and enable B pin to Nano 7 and 8 number pin correspondingly. Then we also have given a Bluetooth sensor, uh, a Bluetooth sensor which is used for the purpose of mode switching when our bot will be able to be controlled using Bluetooth. And then we have a sensor, a Polo Qtl sensor, okay, which is connected at the very end of our bot, where the description of which and the further connection details of which will be described by Mehdi.
So as Shemonto described, we are using a Bluetooth module as well as a Qtl sensor for detecting the maze lines. So as we can see, the Bluetooth has its RX and TX pins, and it has been connected with the Arduino's RX and TX pin. As to mention, the TX port has been connected with the RX port of Arduino and the vice versa. Apart from that, there is a Qtl sensor. It is an 8 array Qtl sensor, and its cable, as we can see in the video, it has been connected with the Arduino's analog ports, with A0 to A7. So we have connected the Qtl VCC port to Arduino 3.3 volt, as well as the ground port has been connected with the Arduino's ground port. The project requirement, our bot has two mode. We can perform we can control the bot with the Bluetooth module, as well as it can work as autonomous to detect the maze. So here we have attached a switch to change the modes. So when it's in 1, it means that it is working as a maze solver, and if we toggle it to 0, then it will be available to control with the Bluetooth module from the Android mobile phone. Okay, now let us move to our serial monitor interface, where you can see that our Qtl sensor is providing us the values. Here in the serial monitor, we are seeing that our Qtl sensor is passing the values, and the motor is moving accordingly. So here the 60 means which motor is driving the car currently. So now we have toggled our switch to Bluetooth control mode, as you can see in the hardware switch in the right side of the bot. So if from the Android app, if we press the forward button, the bot start moving to forward, and here's the brake. So it's the backward, left, and right. So it shows that our bot is fully controllable from the Android app.
Myself, Shoaib Ahmed Dipu, and I'll be demonstrating maze solving flowchart and code logic part. At first, we will have to select the mode. If the mode is 1, then it will check the calibration status. If the calibration status is false, it will calibrate until the calibration is done. once the calibration status will be turned to true, it will start solving the maze. It will call the PID control method. Then it will determine the position and calculate error. Then set the PID values. Then calculate motor speed. Then update motor speeds, and then it will call forward brake method. And then this method will set the position value, and the robot will move accordingly, and it will solve the maze, and then it will stop. And but if the selected mode is other than one, so it will be in Android based Bluetooth control. It will move forward, backward, on left, on right. So that is from maze solving flowchart part. Now I will demonstrate the code logic part. As we have discussed earlier, our robot will have two modes. If the selected mode is 1, it will solve the maze autonomously. If it is other mode, it will be controlled by Android app. So the main purpose of the robot is to solve the maze, and the maze solver algorithm is basically determining the position value. If the position value is higher or lower than 3500, then the robot will turn left or right. But if we put this in a loop, the robot will oscillate until it eventually gets off the track, and this is where PID control comes in handy. The most distinguishing feature of PID control is the ability to accurate it as it automatically applies accurate and responsive correction to a control function. The distinguishing feature of this PID controller is the ability to use three control terms: proportional, integral, and derivative term. We have to adjust these values so that the robot can follow a line without oscillating or slowing down or getting off the track. And after that, we have initialized the max speed and base speed for the motors. Then we have set up the values for drive motor carrier pins, and we have initialized the sensor pins, and then we have set the emitter pin. And if we select the maze solving mode, if it receives 1 in selected mode, it will check the calibration status. If it's false, it will call the calibration method and it will calibrate. So it will come to here and do necessary changes to calibrate. After that, it will change its status, calibration status to true. So it will goes out of while loop. Then it will call the PID control method. So this is the main maze solving algorithm. So it will have this position from the sensor values. Then it will calculate the error, and then it will calculate the motor speed. After that, it will update the the speeds of both of the motors, and then it will say update the values here. After that, it will call the forward brake method. So and in forward brake method, we have set up the values for the robot to move accordingly to solve the maze autonomously. It will solve the maze autonomously and will stop. So that was from maze solving part. And then if we select the other mode, it will be in Android based Bluetooth control mode. So if we press a button, it will receive a character in Bluetooth character, the Bluetooth char variable. So if the received character is F, it will call the forward method, and then we go forward, B for backward, L for left, R for right, and S for stop. Suppose it receives a character F, so it will call the forward method. So it will be here, and then it will do some necessary changes to move forward, and it's same for back, left, right, and stops. So that's it.
So hello everyone, this is Nayem-Ul-Islam. I will show you our MIT app inventor part. This is user interface or design diagram, and this is block diagram. So whenever I will click Bluetooth icon in our app, then our device will search available Bluetooth in my phone, and if it is matched with our Bluetooth module, then it will connect through app. You connect through app Bluetooth connection, and it will be shown connected, and our text color will be green. If it is not, then it will show disconnected and our text color will remain red. So let's move to button part. Whenever I will press button 1, our app will send F to Arduino through Bluetooth, which means that our bot will go forward. Similarly, if we press button 2, uh, our our uh, our app will send R to Arduino, which means that our bot will go to right. Similarly, if we press button 3, our app will send L to Arduino, which means that our bot will go to left. If we press button 4, our app will send S to Arduino, which means that our bot will stop immediately. And if we press button 5, then our our app will send B to Arduino through Bluetooth, which means that our bot will go to backward. So that's all for me. Thank you.